Good morning, everyone, and welcome to Autodesk Virtual Academy, our once-a-week learning webcast for all the Autodesk software you and your team use every day. So I'm Nigel Mbayak, Application Engineer, and your host for today. I'm also joined by Jonathan Kriek, one of our application engineers here at KETIV Technologies. Good morning, John.
Good morning. How are you doing?
I guess it's afternoon for you. You're in Dallas. Is it two hours?
Yeah, it's just lunchtime now.
Nice. So yeah, instead of his lunch, he gets to present for us. So hopefully we don't keep you too long, John. So as of the last couple of months, I know that we've done a lot of iLogic webcasts, specifically the iLogic series of webcasts by Thomas Fitzgerald from Autodesk. And we just decided, keep rolling with that, keep that momentum going. So Jonathan Kriek here, our in-house iLogic expert, or at least one of them, is going to go ahead and show us some really cool ways that he took as a design approach for some of the problems that he's seen for our customers. And John, if you want to explain that a little bit more in regards to the generative approach versus like the master model approach.
Yep. So let me first, give a quick synopsis here of myself. So like Nigel said, I do automation here at KETIV as well as other things, vaults and PLM, but I've been doing this type of automation for over 20 years. With Autodesk products, it's been more around 16 or 17 years. So that's, using the Inventor API. When iLogic came out, that became a shortcutted way to do that. So, that's my goal. That's my passion, is figuring out how to reduce the design time, increase your productivity, and get them out quicker to market. Whether that means that, we'll do the comparison here in a second, between this more master model approach, or what we call configurators, or this more kind of generative capabilities that we're gonna look at today. And again, ask questions anytime during this presentation. Just pop open the question, and we've got Nathan and a couple other people, ready to answer those, and then we'll have a Q&A session at the end to answer any outstanding questions. So our agenda, we're gonna compare that model, that master model that we just talked about, which is the more traditional approach, to the generative. And then we're going to dive right into it. There's quite a bit of code, and I'm going to break down each of the different sections and how we actually achieve this. And then later we're going to talk about some packages that are going to be available to you. So let's compare what we call the master model approach. It's what most of our customers are using, and there's really no slights to this. These aren't pros or cons necessarily. It's just saying these are the limits of the capabilities and how you have to go about building these models. So in a master model, it's basically what we call self-contained. That means that before you start automating, you have to build that model. And a lot of our iLogic sessions for AV8 previously have gone over, sometimes you have to model things a little bit differently if you're intending on automating them. Or if you already have existing models, you may have to go tweak those. That means things like face-to-face constraints or geometry constraints may have to be switched to more stable constraints like work planes, axes, work features, and things like that. So you have to go and build that model first. And then you generally go through and you constrain all the components, including components that you may want to switch out. So constraints are not easily adaptable. You generally go in, you constrain your model for your purpose, and then later down the road, iLogic is going to change parameters based on user input. That's what we call a more of a configurator. So it's going to start manipulating components that you've already placed inside of an assembly. If you have something that deviates from that, you have to essentially maybe create another master model to achieve that. So with that, you may be putting 4 or 5 different, in this example of this chair, I might be putting 4 or 5 different arms models into my master model, and I might be hiding those with level of details or LODs, or I might tell iLogic to start replacing those components. So you have the need to either hide or replace those components if they deviate from your original design. And then when that's all said and done, and a lot of our customers, they're completely okay with this, right? So they're going to take this master model, they're going to run iLogic on it, they're going to configure it, and then they need to, they don't want to modify that original model, so they want to go and actually make some production parts, right? So for a particular job per se, right? So we can use Design Assistant. A lot of you guys have Vault, so you're using a Vault copy design process, and that's fine. But when we start talking about things outside of that scenario, where we need to be able to possibly generate 3 or 4 different designs at the same time, maybe we need to actually run through and generate all the options for a catalog or something. That becomes a little bit more arduous process to run iLogic in a master model on all the different master models that you have, and then run it through another copy design process anytime you want to create project-specific instances. So with the generative idea, we're creating the components on the fly. So instead of a master model, we really just have an assembly that has iLogic in it, right? And there's really nothing in that assembly other than some potential skeleton type work planes. It may have the parameters and things that we're going to manipulate. And that's very similar to a configurator. The constraints are generated and can adapt to different models. So basically, it's going to look at the models that you place in there based on that configuration. So for example, in this chair, if I put this in as is, it's going to go, okay, so these are the constraints that I need to put this thing together and turn off all the degrees of freedom. If I change the arm out to something else, it's going to look at a different constraint set. So with the master model, you can replace components, and as long as it doesn't deviate from that constraint scheme, you're fine. But if it ever does, and if you've ever done it, you'll know that your constraints may blow up. And so that's why a lot of times people separate those two things into different models. So they have one constraint set for this scenario, they have another constraint set for something else. So instead of just doing that up front, we're actually going to dynamically create those constraints based on the models that come in. And then we're only placing the components that are needed for that configuration. So, let's contrast that to the master model approach, where we might have to be hiding certain components based on certain conditions. We have to replace components. Again, anytime you replace a component, you have to worry about, are these constraints going to blow up, or are they going to just be fine? So those components will only be placed in there that we need, and we have nothing else in there. It also keeps our models pretty lightweight, right? So if you have a very large assembly that has 25 different scenarios, or variations, having all of those in one model is, it makes it pretty heavy, whereas this is just exactly what we need. And then the final thing is a comparison is that we have the capability using the Inventor API along with iLogic to make copies of these components of the assembly and rename them automatically, not just the browser name that you're seeing inside Inventor, but the actual physical file name. And so in our example, we're going to use a project number and a project folders. That's just going to be, the folder is going to be generated. All the parts are going to be generated with this particular project number. So let's actually dive into it. This is going to be the blunt of today's session. And I'm going to start out by just opening Inventor. There's really nothing else open. I've taken this templated approach so it's easier for users. You can absolutely just tell them that we've got this particular automation assembly that you can go open, but we can, since templates in Inventor are really just, there's really nothing different about those templates. They just happen to be in a template directory, right? So I'll go up to Start New, and I've got an actual automation folder. And so we have this master chin assembly. So I'm going to start by showing you what it actually does, and then we'll dive back into the code and figure out how we actually accomplish this. So when I opened this assembly, it's it started a new assembly 7, okay? It's automatically been told to launch this iLogic form, and there's really 2 simple things in here. Now, if you've looked at some of the other sessions we've had, you know that you can add as many options and things in here to this form as you want, right? So you can add different parameters that will, after this thing is generated, it'll function just like a normal configurator, where it'll actually use iLogic to manipulate parameters. A lot of that is out there. We've provided some code for that and examples of how to modify components based on constraints. So this is gonna focus more on the generative capabilities. The first thing is the chair series. So this is a way to kind of deviate from, if it's a standard, it knows that there are certain components that it's going to need to go generate or grab. So for some components, they may just create one from scratch. Or if it's a bolt, for example, that's a standard or something, it'll go out and grab that standard bolt and place it in here. Versus custom, we have different parameters and stuff for custom. The main thing here is this order number. We're using this order number to give all of the files a project-specific name. When it creates those copies, it's going to go out and, number one, place it in a folder under the, in this case, the Vault structure for that particular project. And then all the names in there, you're going to see that all the files, assemblies, and everything is going to be based off of that new name. So let's figure out a number for that. Let's do 8675309. And I'm just going to hit generate. And this is going to go pretty quickly, but I think when we start looking at the code, we can break it down a little bit further, and you can see how these things are placed. So this model is, it's a pretty simplistic chair, but the combinations are absolutely pretty infinite. So all that happened in just that one go, let me turn off the work planes and visibility here, is that we're no longer in that template instance of Assembly 7. We're actually in master chair 8675309. If I look at my path for that assembly, we're in a project-specific folder with that same number, okay? So we've moved away from the template, and we use that as an instance to now dynamically create this assembly. In this assembly, we now have two arms, we have a seat, and we have several different bars that are in place here, right? So for supports, back in the lower and then the top. So there's 6 components that are in this type of assembly, but really the combinations are endless. This could be 25 different seat types. There could be different shapes of these things, and based on those, potentially all the constraint systems might change. So that's where we're talking about the strength of this, is that quickly we can go out and grab those components. We don't have to have them pre-assembled because we're assembling them on the fly using constraints and the Inventor API. And then further down, the last part is actually manipulating parameters if need be. So maybe this component isn't, I don't have 4 different parts necessarily for it. Maybe I just want to manipulate the parameters for that. And all these components were out essentially in standard parts or places, but it has looked at this particular configuration and went out and grabbed those and created, again, if we look at the paths for these things, they're all project specific now. So we've already done the copy design process, we've done the generative process, the creation, and the constraints all in one go. So the first code is on open. This is pretty simplistic, that we're only telling it as you start the template, we want to show that iLogic form. We want to present that to the user, okay? And that is in this section over here with form. So it's really as simple as just clicking on show form, filling out the name. So there's really nothing major with that. The next part is the master, and this master is really, and we could break this out a lot further, but it's really kind of our master rule. And so I'm going to kind of go through each section and kind of explain what's iLogic, what's Inventor API, what is actually we're telling it to do. So the first part is we're doing some directory checks, okay? And so this is the Inventor API. This is the syntax. If you've ever used VBA, everybody at Autodesk and really at KETIV and a lot of other companies use VBA inside Inventor, inside other applications to do development. The reason for that is that we have IntelliSense, right? So if I start clicking on, if I type this out and I hit this application and then dot, it'll give me all the available options, right, for that. So it helps you write the code. The other thing you can do to get this type of syntax is you go up to the help section over here, and you go down to help, and then programming API help. When you open that up, this is not necessarily going to give you iLogic syntax, but what it will do is the syntax for how the API works. And really, iLogic is that shortcutted API with more with .NET capability. So it has a lot more capability than just VBA, but it still includes the Inventor API. So there's two different kind of ways to get this syntax, but I'm going to explain really what it does. So we're assigning assembly doc as an assembly document object type. So that's assuming that we already have an assembly document open. That equals this application. That's the Inventor application and its active document. Now you could add a bunch of error checking in here to say if it is really an assembly document, then go ahead and hide that, or assign that. If it's a part document, maybe give an error or something. And then we're actually assigning its component definition. So we're going now further down into the assembly to get its component definition. Under that component definition, we have lots of things. We have the ability to look at parameters. We have the ability to you look at its children, essentially, right? Components of the assembly. And this assembly that we are attaching to was really initially that first assembly template that we opened. So basically, we already have transitioned past that now. The second part is what we want to do is we want to get the work planes of that original assembly, okay? And so we're assigning transition geometry. This gives us an ability to create proxies for work planes, something that the program can attach itself to. Now you could name these. This is just assigning a name, master assembly plane XZ, to the first work plane. You can actually list this out if it has a custom name, right? So we're just assigning it to the first 3 planes here. We have some additional planes here, and again, we can call out the number if it is, since we're generating this on the fly, we have the ability. We already know that the first 3 planes are going to be the origin planes, and then the next 4 planes are going to be planes that we're using as part of our skeleton. So we can add those numbers, or we can actually define the actual name of the work plane, and we do that further down inside the code. The next thing we do is I'm looking at, and this is going into .NET, this is going into Visual Basic. It's not necessarily part of the Inventor API. It's just something that the iLogic can tap into, okay? So I'm giving it a path, right? It's going to be a job-specific folder, and then based on that order number that we entered into the form, I'm just doing a system IO directory exists. So basically, I just want to make sure that this path exists. If it doesn't exist, then we have a clause for it, right? So we want to create that directory if it doesn't already exist. So we're doing a simple if statement to say, if it exists, fine, don't do anything with this. If else, go ahead and create that directory, okay? The next part is we're actually, and this is really the kind of the key to this. It seems really simplistic when you look at the code, but you see what we've achieved. And there's actually a couple different ways to go about this, but this is the one that's most consistent. Is, again, we're doing a file, instead of a folder exists, we're doing a file exist. And we're basically saying if this assembly has, this path here, this order number, which is going to be our new assembly. That's the new assembly we're creating. And obviously this path can change. We can have dynamic paths. Right now we're just offsetting that path with a specific order number off that original path. So we're saying if this file already exists, then that's fine. Otherwise, we're going to do this document. And now this is iLogic syntax. This document save as the master assembly, which is our string here. And so it's actually going to take that as assembly template, and it's just going to do a save as into that project-specific directory. And at that point, we just have a brand new assembly that's now project-specific for us. The next part is, and you can break down your code in sections with these little this syntax. So it's just the bracket and essentially the comma essentially. Which allows you to kind of hide these sections, because these sections can get quite long. So the first section is we're actually pulling in the arm. And we do the same thing we did essentially before, is we're going to give it a path, and then we're going to make sure that if it doesn't exist, that we're going to go ahead and create it. And so since none of these actually already exist, it's just going to start creating these as we go along. So we're hard coding the path to where these components are. There are more dynamic ways to get those components or define those components. But this is the most simplistic way. I think you'll get the concept of, yes, we're hard coding it now, but you could do other things with it. So for this example, it's just hard coded. And obviously we were doing a little bit of error checking. So if it can't get that, can't save that file, if it can't find that file, we're telling it that the ARM already exists or it doesn't exist. There's a part creation error. But then at the very bottom, what we do is we now open that actual document, and then we do a save as. Okay. And what this is doing is it's actually going to be placing, it's going to be opening that component, it's going to be doing a save as, and then it's actually going to be placing it into the assembly. So the next part is we're going to assign OCC as occurrence. So we're trying to grab this new occurrence that we just saved, and occurrences add. So under that same assembly definition, that's the assembly we have here. It's going to look at its occurrences, and the function just is add. So this would be the same as if I just said, hey, go out and find this component and place it in there. So this is just placing it 000 in here, and it's going to give us an opportunity now to go and constrain it. So the second thing we do is when you place a component generally like this, it's going to be grounded. So we want to turn grounded off because we immediately want to constrain it without really any input from the user. The next section is I'm defining as a work plane, and you notice the work plane is coming up in purple. Okay, so I'm assigning a variable, a placeholder, a string for this particular work plane. And we're attaching ourselves back to this ARM occurrence, right? And its definition, and under its definition, similar to component definition, we have access to work planes. We have access to a lot of things under this definition, but we're going to attach ourselves to work planes. And these are actually calling out the names of the work planes inside of that part, right? So we're just assigning, we're going to grab those essentially. The next part, and this is a good concept to understand, and I know Autodesk has several different examples of why this has to happen. Assemblies are really just windows, right? They're essentially databases into the parts. So when you want to apply a constraint from a part back to an assembly, there has to be a middleman. There has to be what we call a work plane proxy. And so that's exactly what we're doing here is we're assigning some more names to a work plane proxy. So it's going to create this object in between it, and then it's going to enable us to make a constraint between a work plane inside of a part, or really any object inside of a part, back to this top level assembly. So it's assigning the work plane geometry. This is where we're actually creating the geometry, the proxy geometry. So that's that original work plane here, and then we're assigning it to that proxy. Again, the work plane, we're assigning a proxy. So it's just making a link between the two essentially. The next part is we're going to actually execute constraints. And I would encourage you to potentially take some of this code and look at under constraints your options, right? So you have all the available options as any other. If you were going to go constrain this manually, you would have flush constraints, make constraints, angle constraints, things like that. So we're just applying some simple make constraints. We'll notice that we're assigning it back to the assembly work plane. And then our proxy, we're not going directly to the work plane in the part, but we're assigning it to our proxy ground plane in this case. The next part is actually the offset, right? So we're going to do a 0. In some cases, you may just want to have an offset. You may want to say that this is actually 5 millimeters or something off the ground, or offset in that way. So you have that ability to not just go 0 to 0 face to face with these work planes, but you can offset them as well. The last thing we do, and that is fully placing, creating, and constraining just that ARM component, okay? The last thing we do is we just tap into this application, the command manager. The command manager is actually really cool because a lot of these buttons that you click inside Inventor, they're actually accessible. There's an actual command that's triggered in the background. So when I set F6 or I use my view cube for isometric view, we can actually just trigger that without much trouble. So the next section is we're doing the arm, the other side of the arm, and it's exactly the same. The only differences here, and I'll kind of walk through this a little quicker, is that we're assigning it to the second instance. Again, since we're generating this, there's really not much issue. There's not many times when I'm going to get a component that I don't already know about, that I'm not expecting. So this is the second, the order of operations. I know that I'm going to place 2 arms first. So we're attaching ourselves to the second occurrence of the assembly. And then the code is essentially the same. Down here, we may change a mate and a flush constraint. We may switch a flush to a mate or something like that. The cool thing about this is that when you generate this and you get your finished assembly, if you go through and you see an error with a mate or a flush, normally when you're constraining manually, just using Inventor, it'll give you an error like, hey, I can't do this because I'm flipping the work plane. And it'll make you change that, right? So we can just generate it. And if you do generate that and you realize there's a problem with it, then you just come back to your code and say, okay, well, for whatever reason, it was pushing this side versus this side. Let me change that mate constraint to a flush constraint, okay? And we are using an offset here. So this is a good example of an offset. One tip on this is that whenever you put a number, it's going to be in centimeters, okay? So that when you deal with the Inventor API, it's always going to be centimeters. If you want it to use whatever document units that the assembly or the part is already using, you need to actually put it in quotes and make it a string, okay? So rather than putting just 590 in here, that would come as 590 centimeters. But since I've put it in quotes, it's just going to use whatever the document units are, in this case millimeters, to apply that. And that's also this function, constraints, add flush constraint, add mate constraint. It tells you in that API documentation how you can switch that. Now we do the seat, and really all the thing is changing here is the paths that we're going to create the parts to, as well as where the components are coming from. These all have very similar work planes that we're using. They don't necessarily have to. Now everything has to be from the origin. So mid-plane to mid-plane, back-plane to back-plane, ground, the origin planes don't have to be used here. And so we go down to the bars, and this is where it gets a little bit more complicated, is that we are actually potentially deviating from the origin planes. Maybe we're taking custom work planes. These work planes can be anything because now we're naming them by name. So it's just going to find a work plane with the same name as mid plane, back plane, and ground plane. You could call it really anything, offsets, things like that. When we get down to these lower bars that are actually drilled holes, we have some edge planes, right? We have the mid plane and back plane, but we have certain edge planes. So I'm just kind of deviating. And really how I figured this out is I assembled this manually to begin with. Now you're saying that, well, if I'm going to assemble it, manually to begin with, in order to figure out how I need to program this, then what's the point of doing it that way? Well, this has the capability to build that over and over and over again for different scenarios. So you might be playing with it a little bit to get what work planes or what work planes you need to actually constrain things. But I think as you understand the code a little bit more, you do less and less fooling around in the model, and you just do more straight programming inside iLogic and using the Inventor API. And so this really repeats itself. We're doing the same procedure in order of operations that we want to constrain things. At the very end of this, once we've established that everything has been saved and placed and created, then we run not external, but we run another rule that's called push matching values. And what do I mean by that? Pushing matching values. So when we created this assembly, when we had that first initial dialogue, it asks us for two things: the chair series and the order number. So one of the requests we've always had from customers is, I want to push properties down to these other parts and things that I do. And it's never more important than when you're dynamically and generatively creating something, is I want that order number to carry, if it's a project number or order number, I want that to be in all of my parts and components, so that if I ever grab one of those things, I know where it belongs at, as well as any of the parameters that I want to control these parts with. I don't necessarily have to use iLogic to call out this specific component and change that value, because this component name may actually change. The browser name may actually change, because this is all dynamic, right? So one of the ways that we can do that generatively is I can just put these, whatever parameters I want to change. So I could put, chair height in here. Whatever's inside your master assembly here, or your top level assembly, is going to be carried down to all these components. And so let's look at that really quickly. It's pretty simplistic, but it's basically saying we're assigning to this assembly definition, again, this active document. We're going to look at the occurrence. We're going to loop through all the occurrences, okay? So we're going to say for each occurrence in occurrences, that's just going to loop through all the parts and things that are in this assembly. And it's going to say that basically if the parameter name in any of these components matches the parameter name inside my top level assembly, then go ahead and set that value. Okay, so that's a really quick way, a very simple function, essentially, to enable me not to have to dive down into components constantly, or remember the names or hard code the names of those components that they may actually change, right? Remember, we're using a project-specific file name, so that becomes a little bit more difficult to target and change the parameters, whereas the normal iLogic way of changing parameters. So this is just going to copy those values down from this assembly to those components. If the name matches, of course, okay? That's why we have this try catch statement in here to say that we're going to set the name if it matches, essentially, and it's not going to error out, if we have a problem with that. There's other ways to do error checking on that, but that's one of the most simplistic ways, is just to set the parameter and don't apply anything under the catch statement. So that runs, so down inside of any of these components that are customly created, if I go into the parameters, I'll get the chair series and order number. So that could be manipulating all these parameters and stuff too. So that's the more configurator part of it, right? Switching those parameters. So, but we don't really have to do a whole lot there. We just have to make sure the names are exactly the same. And then at the end of our master rule, we do a little bit of cleanup, right? So we set the isometric view again. We've been setting the isometric view, changing the view every time we place a component. And then we're doing rules parameter output for any of the parameters that we want to change, and then we're updating the document. So that is why I have the show for you today. And we're going to switch back over to Nigel, and I kind of want to touch on it just briefly. We've got a lot of requests from our customers time and time again to get coding samples. And so we want to oblige that in the best way possible. And not just for iLogic, but we're actually going to carry that forward into all of our applications. We're going to start offering KETIV automation packages. I think the name's pending, but I think it encompasses what we're after. So right now, today, we have this code that we just went over, this assembly, this entire package we're going to provide to you, okay? In the future, and we've got a lot of other things in the works, so we're going to be providing these code packages as really samples, fully working examples for you guys. And that can include Lisp routines in AutoCAD. It could be VBA in Inventor AutoCAD. It could be using PowerShell for Vault, JavaScript for PLM. There's lots of different things that we want to provide to you that aren't really, they're not customer specific coding examples. They're just really generic. And I think that's going to empower you guys to start playing with this code, have a working sample that you can go, hey, I love this generative design concept, and I want to take it and play with it, and see if I can come up with something, right? And then if you have any questions with this at any point, we're available to help you with that. And we want to kind of extend your capabilities. So the use cases for this is, right, if the configurator approach, you liked it, and you said, well, I just have too many different variations, right, to basically build all this stuff at once, and you need something more like that, then you can look at this sample code and potentially get an idea of what the effort is involved with that.
And yeah, there are like 5 or 6 people who mentioned already in the questions that they'd like the sample of this code. That is pretty resonant with all of the other iLogic topics that we have done in the past. And yeah, so we just want to oblige to that and be able to address some of those questions, because most of the time we can't give away that information, seeing as it's proprietary information or like projects that our team has been working on for customers. So luckily we're able to come up with a solution for you in which you can use this plug and play code. You can just insert it into your file. Sometimes, depending on what it is, and just be able to start running with it. You can see the examples that we have and comment on it. So you can see, how I want to build this on my own to, address my design issues in the same way that people here at KETIV have kind of automated those problems. And 3, you can use that code to teach yourself, help you understand how the code was built and why we use certain things over others. So like Jonathan mentioned, if you do have any questions for us from this webcast, so I already noticed some people have been starting to put them over into the questions panel, but go ahead and add them if you do have any additional ones. I think we've already addressed the, hey, can I get a sample of this code question with the last couple of minutes here. But there are a few more here pretty important. Let me go ahead and run through these for us, Kriek. First one, is there a way to for Inventor API to search a Vault database for existing components?
Okay, so the iLogic and really the Inventor API is really its scope is Inventor. Okay, so Vault has its own API. Now that's not to say that you can't create a .NET add-in and use the Inventor API and the Vault API together. But you would really have to create that to accomplish that. iLogic has no capability to interface with the Vault API. So generally with these type of things, we make sure that if it's in Vault, that we pull out these components. If they're templates, we make sure those things are pulled out, that you have those available to the program, and then we run the program. But that's not to say that that capability isn't possible. It's just not with iLogic today and the Inventor API.
Certainly. There's another Vault question. Can I use Vault AutoNumbering schemes with these dynamic file names that you've used iLogic to generate?
So that's one of the areas that is kind of the caveat. So the Vault AutoNumbering, there's really not, even with the Vault API, there's not a whole lot we can do with that. But since this is, we're doing this all from Inventor, there is data standard. And data standard is a way to extend the interface and essentially some of the capabilities of Inventor, AutoCAD, and Inventor. So we can absolutely use data standard to tap into the Vault numbering scheme and then pull that into our automation. So that's definitely a possibility.
All right, so let's keep on moving here. In regards to the iLogic or automation packages, how is the delivery going to be? What's the deliverable there? Is it going to be a link to download? Is it going to be a flash drive? Kriek, do you know the details on that?
So it's most likely going to be available online. We'll probably build those into zip files, make them available on the website. I'm used to keeping my code in something like GitHub or Bitbucket. I like Bitbucket a lot. So for the code itself, there's multiple different ways we can apply that. But since it's already inside the models, what I'm getting at there is that I can provide this assembly with this code. But if I ever update that code, you'd have to essentially go re-download that, right? If somebody said, hey, it'd be great if that was in there, something like Bitbucket being cloud-based, if I update the code, everybody can essentially get that code immediately. So there might be multiple platforms. There might be an initial platform to download the assembly, the parts, and the iLogic that's embedded inside the components. And then there might be something like Bitbucket for ongoing code improvements. Does that make sense?
Yeah, and I think that, depending on what kind of automation it is going to be, it's going to be put up in a different kind of way, because obviously not everything's going to be Inventor iLogic assemblies. We're going to jump into JavaScript for PLM and things along those lines too. And those obviously, depending on what it is, it can't live in the same place, or at least not optimized to live in the same place.
Sure, absolutely.
Yep, and then we just got a comment. Impressive. I didn't realize iLogic and VBA could be used to generate components. I thought it could only modify existing components. Definitely thank you for that comment. And yeah, so hopefully we opened some eyes today as to the power of some of these tools in iLogic and Inventor. I know, like for me personally, rule of thumb is generally the Inventor API can do whatever you can do as a user in Inventor. You just have to know how to do it and where that command lies somewhere. Would you consider that correct as well, John?
Yeah, and to the points, the point of the last question. A lot of, like I said, a lot of Autodesk and obviously and a lot of KETIV employees start in VBA, and the syntax is the only thing that changes. So in VBA, you're saying you're calling something and then you're setting it. You remove the set in iLogic, and we can condense that code down by looking at this example. You don't necessarily have to call the name twice, like assembly is this type of object and assembly equals this object. You just say assembly as type equals object, or object equals something. So it's simplistic, but it really is the same API that you would use in VBA and Inventor and .NET as well. So
cool. So we got a couple more here. Hopefully we can address all of these before we end today. Does iLogic and Inventor API have the ability to tap into the stress analysis functionality built into Inventor?
Into the stress analysis, that I don't know. I've never tried to use the API for that. I would say let me look at that. You're welcome to look at that section, that API help section that I showed you. And if it's not listed in there, then I would say it's probably not. But we can also follow up on that and see if there is any capabilities to initially automate that stuff. But I don't think I've seen anything in the API for that.
Yeah, I don't remember seeing anything either. I've looked through that list, and I've got a giant list on Grayson's desk here. I just looked and I didn't see anything that stuck out to me. In regards to things that it doesn't work with, I've heard in the past generally tube and pipe and frame generator are things that iLogic tends to have some issues with. Kriek, do you want to address that?
Yeah, so the frame generator, a lot of those environments, those tools, those generators, they're their own separate programs essentially that are running underneath Inventor. So Inventor really doesn't have the ability to, you can definitely trigger those, right, through the command manager. You can trigger any of those commands just like you were pressing the button. You can do that just like we changed the isometric view by using the command manager in our code. But manipulating the values and things of that, we can't tap into that. Now, that's not to say that once you've created those components, you can't do everything, but you can still manipulate them like the regular components or parts to a certain extent. Some of them are read-only, like frame generator parts. They're locked down, parameters and things like that, structures locked down, but you can still manipulate them, constrain them if you want to, right, using this method. Yep.
And then just last but not least, Kriek, you mentioned IntelliSense at the beginning of the webcast here. Is there a way to trigger that in iLogic, in the editor specifically, trigger that on and off?
So there's no way currently to do that inside iLogic, and that's why a lot of us use VBA or even Visual Studio for that IntelliSense. Now, later down the road, that is something that Autodesk is looking to improve iLogic. So this is the future, guys. iLogic is going to be the platform from here, really here on out. It's going to have more .NET capabilities. It's going to have potentially IntelliSense to help you write the code better. So there's not really any time frames on that, but that is what they're working towards right now. So right now it doesn't have it, but future it probably will.
Certainly. And I know that's something that they've been working on for the for the new releases. I know that I've talked to a couple of people on the Autodesk product manager side of things, and that's something they've been looking to improve for the last couple of years. So definitely be on the lookout for that, or even be part of the beta program and be able to see it first. So that's another thing too. So if you are interested in the beta program, let us know. We can definitely get you connected with the right kind of people with that. We also did an event last year called Inventor Insider, which is like an Autodesk gunslinger, in which some users, I know I see some of you here inside of the attendees list, attended and got to work in the 2018 release pretty much of Inventor late last year. So even like months before it came out, and test its capabilities, things like that. So expect to see something like that from KETIV in the next few months or so. And a couple more questions. Last one here. What about iLogic and Domino, Kriek? Anything about that?
So iLogic is, and that's where I think, people don't know you can tap into the Inventor API, but you can also, iLogic is .NET capable. And what that means is really anything on your machine. Now, that doesn't mean that the iLogic is going to have a specific function for that. Like Go Excel, that's an example of an iLogic specific function that accesses Excel. But you could actually absolutely use Visual Basic Code or anything else that the .NET can access. So if you can pull in a reference to Domino, you can absolutely use it with it, right? It may not be the most efficient because now it's pulling something else into the Inventor application, whereas .NET would potentially be outside of the Inventor application. So you kind of have to worry about, utilizing your RAM in the session, not crashing Inventor and things like that when you start tapping into those other APIs.
Definitely. And I forgot to comment too, Kriek. Your part numbering scheme is quite clever. I just wish you would have sung those numbers instead. That would have been really interesting.
Yeah, you won't hear me sing.
Certainly. So for those of you who maybe this is your first iLogic AVA, excuse me, we do have tons of content on our YouTube channel. It's probably like 4 or 5 hours of iLogic specific content, maybe more than that, on our YouTube channel. That's going to be youtube.com/KETIV Technologies. Or if you just go to YouTube and you search KETIV iLogic, you'll be able to find all of those videos. There's probably 4 or 5. And we're in like still of our iLogic series with Thomas Fitzgerald. So definitely go ahead and watch that playlist on our channel if you are interested in learning a little bit more about iLogic and how it can help you and how you build your designs. I think that's everything here, Kriek. But if you do have any further questions, anybody, go ahead and give us a call at that number below, or shoot an email to questions@ketiv.com. And for those of you who did let us know that you wanted to see more contact for the automation packages, we'll be reaching out to you shortly. So, Kriek, I'd just like to thank you for being here today. Nathan as well for being in the background, helping us answer some questions. Anything else you want to add before we go, Kriek?
Let's automate the world, guys.
There you go. Maybe that's what we call this presentation in the future. So we'll see you all next week for some 4 and 5 axis CAM capabilities in Fusion 360 Ultimate. If that's something you do in your office, you do your machining at your warehouse or your facility, want to be able to leverage some of the power of a 4 and 5 axis CAM without having to buy a separate program even. Fusion 360 is there for you. So with that, I'll let you all go today. Thanks, Kriek, for being here, and we'll see you all next week.